Okay, this project demonstrates how an Arduino Nano converts an analog voltage into digital data using its own built-in digital data using its, or we call it ADC. The data is then sent to a processing application where it is displayed in number, binary, value, LEDs lit up and on and off, and live graph. The LED will show on as 1 and off as 0. A potentiometer is connected to the Arduino Nano. As the knob is turned, the voltage on the center pin changes between 0 volt to 5 volt. So the Arduino measures this voltage using 10 byte ADC. A 10 byte ADC can represent 1024 different levels, produce value from 0 equals 0 volt or 1023 equal 5 volt exactly. But remember that 1023 is actually 1024 because it's from 0 to 1024. The Nano then, or the Arduino Nano then, convert these 10-bit value, okay, into an 8-bit value ranging from 0 minimum to 255 equal maximum. But 255 is from 0 to 255, which is 256 actually. So this graphic display that I made with a software called processing, the processing program receives the data and display it in several ways. Voltage, show the actual input voltage applied to the analog pin, the 10-bit ADC value, display the raw Arduino reading from 0 to 1023, and 8-bit value show the converted value from 0 to 255, which is a commonly used in digital system and computer graphic. So the binary display shows the 8-byte value as the binary number made out of the ones and zero. Example, decimal 128, binary is 1 and 7 times 0 roughly. Okay, so I don't have to explain this, but you can have an idea. So you can see the 8 on screen LED represent the 8 bytes of the binary numbers on and off. So we start from 0 volt, which is all the LED will be 0, mean 0, will be off. And as we progressively move towards 5 volt, all the LED will be on, and that will be equivalent of 1 in binary number. So the 1023, it's a digital integer input that Arduino creates inside its own memory. Okay, so the Arduino Nano cannot understand raw voltage directly. So it uses an internal tool called an analog to digital converter, and we call it, we shorten as ADC, to convert that smooth physical voltage into a digital number the computer chip can process, because the Arduino Nano has a 10-bit converter. It divides the electrical range into exactly 2 to the power of 10. And a lot of people get confused when they code because they use analog write instead of analog read. Or they confuse that practically. Analog read is reading a voltage input, read input. Analog write can manage the brightness of an LED or some other sensors or microsensor, or power using PWM, but it's a control output. Okay, one is control output, one is reading input. A bit different. So we practically have gone through this project, which has we manage analog and digital signals, voltage measurement, analog to digital conversion, ADC, 10-bit resolution, 0 to 1023, 8-bit resolution, 0 to 255, binary numbers, serial communication, and real-time data visualization with the project that I made. So this is just a simulation, but it's at the same time a simulation and schematic. So it shows how everything is connected, the Arduino Nano, the potentiometer, the connection of the 3 wires of the potentiometer with the positive and negative, and the wipers, the signal, which goes to the AO, it's analog 0 of the analog pin of the Arduino Nano. So as you can see, adjacent to this simulation project, there is the code, the code that you can input in. You can put those code in, and those code will run the simulation. And at the bottom of the simulation, you will have the serial monitor, which will show you the information that you will receive from the variable resistor. Sorry guys. Sometimes it's good that you use simulation and coding instead of using the real chip and the real sensors, so you don't actually fry anything, you don't sort of damage anything. This project, at the end of this project, demonstrate how an Arduino Nano just easily convert an analog voltage into a digital data using its built-in analog to digital converter, ADC. The data is then sent to a processing application, which I created with a software called Process, which works with Arduino IDE, where it is displayed as a number binary value, LEDs and live graph. Okay, so the next is a couple of ceramic capacitors that you need to add on. One is on the railing, positive and negative, and the other one is on the pin of the that goes from the Arduino to the potentiometer, and you use, it doesn't matter if it's a positive or negative, but it's that's the way it works. It reduces the electrical noise. Okay, now we summarize everything, and thank you very much. I hope you like it, and I think you give me a thumbs up if you like it. Okay, well, have a good day, and you're ready for the next one.